Hi, this is June. In this video, I'm going to share with a project I recently did in quantitative portfolio management. My goal with this project was to create a serverless, cost-efficient architecture for automated quantitative portfolio management. I actually have a plan to move this into online tutorials, so I would like to hear any thoughts you have about this idea. A quick note before we start the introduction. So this project is only for educational and technical demonstration purposes only. It does not constitute any financial or investment advices. Okay, let's move to the theory. I think every quant researcher loves it. So in this video demonstration, I choose a very fundamental model in quantitative portfolio management, which is called mean variance optimization. Just imagine a scenario that you are creating a portfolio, which is composed of 50 stocks. Then you need to ask yourself a question. How much should I invest on each stock? Try to guarantee that I'm going to reach, the portfolio is going to reach a target. So in the problem I defined here, the target is to minimize the risk. Of course, when we do the optimization, we need to set up constraints. So I have some constraints here, but you can add more in practice. So for example, I need to make sure that the beta with this portfolio equals to a beta target. And also, I want to make sure that the expected return of this portfolio is greater than a threshold, which is predefined. And if I want to invest all my money on this portfolio, then of course, the sum of the weights should equal to 1. And finally, I only accept a long position in my portfolio, which means that the weight for each asset must be non-negative. Okay, I try to repeat. I don't know if this model is going to work or not work in industry, but this is only for demonstration purpose. And there's no financial or investment suggestions here. As a quant researcher, it is not hard for you to solve this problem. Uh, you can use Python with some packages and set up the linear programming problem to get the weights. But how about the practice? Okay, you get the weights by solving that optimization problem. But then you may feel, well, it's still hard to trade. Why? Because there are a few problems that as a quant researcher, you need to consider. And it's actually not easy to solve. The first one, dirty data contamination. There are so many data sources in the market. And I'm trying a lot as well. Then I realized the change of the symbols, for example, for the US market is actually quite hard for me to get a very clean data. And sometimes I have an asset, but then that is a different symbol. The symbol looks a little bit different, but the movement of the price is almost the same. So in that case, it's going to cause, for example, the corrupting of the estimation of the sigma matrix. Another problem is about deployment latency here. So I do backtesting with a Python notebook. Then how I can use that results or like that part of the Python notebook to do live trading. And agility and the configurations here. So for example, I do backtesting. I realize for this algorithm, I need to adjust a little bit about the parameters. So in that case, can we just update the parameters without rewriting the code bases here? And then it's about infrastructure scalability here. So how do we spin up a new environment? For example, now I focus on the US market, then I need to move to Australia. So I want to quickly do deploy all the infrastructure, all the algorithms in minutes, not in weeks. So how can we do that? So to solve this problem, then I developed the Chopin project. And I wish that project is going to help you to implement your trading strategy. So this is the workflow of the Chopin system. Because I'm doing low frequency, like a monthly or like a weekly, so therefore I don't need to have a streaming data. And then I use a clock scheduler and the clock run. Well, that is also good for me to build a cost efficient system. So with the clock scheduler, you can set up the time you're going to start the system. For example, like 6 o'clock in the morning, or that depends by yourself. So after the system start, then it will download the market data from the EOD HD. And then the raw data from the EOD HD will come to the ETL process. So in this ETL process, then I'm going to have is the large language models, because I use large language models here to read the metadata and to get the name of the company. As I mentioned, I want to avoid the duplicates in the symbols. It looks like it's going to be a very common issue with a lot of data sources, or some old symbols and new symbols. You always have this kind of problems. Yeah. And also I use DBT. So DBT is easy. I think it's straightforward for me to manipulate the tables to make it ready for the algorithm and the decision-making steps. After I read the raw data, I'm going to save to the cloud storage, which is placed as robo backup. And the cloud SQL here, I'm using Postgres to save the data for me to make it ready for the estimation of the alpha, beta, and the covariance matrix. So I have some functions here for each of them, and they can read the data from the Postgres, and then to calculate alpha, beta, and covariance matrix. After you finish, then you're going to send the data to the optimizer. So the optimizer, we are trying to solve the the optimization problem we defined in the theory. Because every time, for strategies we may have 50 stocks, we may have 100 stocks. The number of the stocks or assets is dynamic based on your strategy. So it's not easy to save in a relational database. Therefore, I use a cloud Firestorm to save this relational data. It's like a MongoDB, yeah. So after do that, then we have the results. The results can be used as a backtesting, or I'm going to execution like over the service. So I get the weights, and then the weights we're trying to decide if it's going to what kind of order I want to have, market or limit. If the amount of investment is very small, then I think a market order is fair enough. But for like large hedge funds, they have a big money. So in that case, they cannot use a market order. They need to use a limit order from the perspective of operation efficiency. So once we decide the order type, then we send the order to Alpaca. So send to Alpaca, and then Alpaca is going to place the order and occurs and save to Cloud SQL. So this is so far the system Hive. And what you can do is that easy for you change or like update the estimates of alpha or beta covariance matrix or optimizer. So I think you guys, as a quant researcher, you are very familiar with this side. then you can focus on this side, and all the other steps, the system can handle that. You may have a question how this system can handle the updates of a new alpha. Then it comes to another workflow. So I'm using GitOps here to maintain all the versions and the infrastructures. For example, so what you can do, you can basically trying to code or test your algorithm locally on your VS Code or Ruby notebook. After you do that, you can just put the stuff in the template and prepare, and then use a git push. So after we do the git push, then the git actions will work it out for you. So git actions will first trying to build the doc images and push to artifactor registry. So with artifactor registry, then the Terraform will deploy the Cloud Run services and also update the workflow. So as you can see, the only thing you need to do is to write your like a strategy in a template and prepared, and to just git commit to the repo, and then everything is ready for you. Okay, so what kind of a solution this project Chopin can bring to you? First one is that we're using large language models driven semantic ETL. So I'm trying to automate pipeline using large language models to contextually filter duplicates. One example I can show is about AACQ and AACQU. Well, if you look at the symbols, it's easy for you to see that the second one is a union, right? But it's not easy for you if there are thousands or 10,000 symbols and you cannot check them one by one. So in that case, we use large language models here to help us improve the efficiency and figure out which symbol should be accepted and which symbol should be removed from the database. Next one is about GitOps CI/CD automation. So in that case, you don't need to care about infrastructure. So you just need to push the code to GitHub, and everything will be automatically built as a Docker containers and then it deployed to Cloud Run. Okay, I'm trying to explain what Cloud Run's here. So Cloud Run, which means that we don't need to have instance to hold the service. So it's a serverless. So in that case, because we are doing monthly or like a weekly management, so we don't need to set up an instance there to run for 1 month, and the most of the time is idle, right? So that's why I mentioned Cloud Run here is a very cost efficient like solution. Modular pluggable architecture here. So decouple execution from logic allows strategy updates. So in this case, as I mentioned, so we have more than one alpha. So if we back to here, we have one alpha, but we may have more than one alpha. We have, for example, you have different strategies. You have 10 alphas here, then which one we're going to choose? So in that case, what you can do, you can just upload the workflow to see which alpha you're going to choose. So in that case, it's easy for you to deploy the strategy. And then Terraform infrastructure as a code. So the entire cloud stack is defined in code. So we can launch a new environment. Like for example, I move to a different region. I move to different, like I need a different database, like a size. So it's easy for us to just change a variable and deploy the system again. Anyway, so this is more like a very say introduction, like some kind of solutions. I'm going to have a discussion here, but I think I'm going to show you some demos. So by looking at the demos, then you can understand how this system works. Okay, this is the basic structure of my project. So I'm not going to have a very deep introduction about the code here. This is just a brief introduction about the project. So there are major four parts in my project. The first one is about Git Actions. So basic idea is how this is going to control what GitHub is going to do after you push the your latest code to the repo. Next one is about infrastructure. So I basically use this. This is for Terraform. So Terraform is going to maintain, like, manage the whole infrastructure of this project, and they have dev and product environment. And then next one is about service. The service, which means they're all code run like a source code, and there are three parts here. The first one is algorithms. So in the algorithms here, I have four parts, like a alpha builder. So you need to put all your alpha estimator in this folder. And the beta builder is like you put all your beta estimator in this folder. And then we have covariance builder and optimizer. So if you want to provide a new alpha builder, you have to create a new name. So now there's a template called random alpha. So which is basically the ungenerated random numbers as approximation or like a mimic the alpha for each axis in this portfolio. Then data pipelines. So this is all the source code we use to build the ETL process. So as you can see, we have some core functions, actions of the corporation. We have the use large language models to clean the names. We also have OHLCV updates or like raw data ingestion, ignition. Okay. So because this project, this demo is for US market. Then I have for the market, I have US stock markets here. But if you want to expand it to the UK or Chinese, like China or like Hong Kong, so you need to create another folder to have a raw, like a filter for the symbols in that market. And then is about order executions here. Because so far we only do the market order, and I think that should be enough so far with my small amount of money. And if you have large money, then you need to do limit order, and the algorithms can be very complex. Yeah. So that's a different story, but I just show I have this mode here. And then next one, the final one I'll say is about like a workflow. So what workflow can be used? Data pipeline. So basically I have the data pipeline to tell me which part, like which function I should call and to make the data to follow this workflow to do the ETL. And then for the trait is like a which alpha I should use, which beta I should use, and which optimizer I should use. And after we do that, and how to pass the results from the optimizer to the order executions there to place order. So that's basically some major components of this project. Okay, we first start from the ETL process. So the ETL process is controlled by the workflows. So the workflow basically is a YAML file, and you can write down all the cloud run address here and to connect them. Because we normally don't update the ETL process in the project. So in that case, I'm not going to show you how to update the ETL process, but rather than to show you how the ETL process works. So as you can see, I have all the cloud run functions here for different services here. And then we have, for example, action managers, active range. Then we need to connect them to make it as a ETL process. So I already built the ETL process here, which is daily OHLCV workflow. So if we click it, as you can see, we have logs, details, trigger, this kind of information. But let's click execute to see how it looks like. So we don't need to have any input, and this can be controlled by the Google scheduler. So, but here I try to manually click it to show you how it works. So as you can see, here's a pipeline. We trying to read the data like code API of the EODHD to get a raw symbols coming. Because for the EODHD, they have a supported symbols. So I can only accept this, use the supported symbols to do the trading. So now it's working. So it's trying to get all the raw symbols. After you get it, you need to check if this step is, successful or not successful. If it's not successful, it's going to pass to the end. If it's successful, then we go to the next level about step raw field. So let's wait for a while. I think it's like 1 minute. Now it's finished. We check the status. It says okay, successful. Then we move to next one. Next one, we do a very raw step of the filter for the US stock markets here. Because this project so far for the demonstration are focused on the US stock markets. Then we check the raw if it's successful or not successful. If it's successful, then we need to read the metadata of the symbols to clean the names. After we do that, we can only keep the unique symbols here based on the names. If for two symbols, if one is basically, if they belongs to the same company, then we need to make a decision to see which one we're going to choose in the database. So we're going to check the unique, see if we find the unique symbol for that company. And then we need to check what kind of range of EODHD is going to support the data. So if you build the range. So after that, then we need to check if the OLHC data is ready or is in the database. If it's no, then we need to initialize it. So if there is a new symbol coming and we cannot find any OHLCV data there, then it's going to initialize to get a data to code API from the beginning of that symbol. Of that, then we're going to check if this step is successful or not successful. If yes, then we look at the condition. We finish or not finish. So after we do that, then as you know, if the company they have actions like a split or like a dividend, then the price should be updated from the beginning of the from the beginning of the data set. So in that case, we need to check the actions and then to see if we need update or not update. If there is updates, then we're going to update it. If no, we just pass to next one. And then for the batch, because for the EODHD, they provided a batch update of all the OHLCV data. So we do the batch and then to add to the symbols we have. And finally, we finish the workflow. So as you can see, that is how the ETL process works. And we normally don't update this process unless we have new data coming. Then we build another ETL process. Yeah. Okay. After we run the ETL process, we have 7 tables. So for these 7 tables, it's going to show us the information about the symbols we have in the database. I'm going to show you a few tables. The first one is the corporation. Say for each day, for example, this is a 12. For this ACV, then what happens here? So we know the date. So when this happens, then we need to adjust the price, right? Because for example, predictive split. Then we have OHLCV data, which is the major table that we can use to do the calculation or to build your own alpha or like a covariance matrix. So I'm going to have order by date and the limit 1 or 10. So as you can see, okay, send. So every time you update the maybe run the ETL process, it's going to update the uh, data for a symbol. And the next one is about the name clean. So if we see the clean data here, I only have 20 symbols here. And let's see order by the code. Let's see order by code. So as you can see from here, we have AACQ and AACQU. Because I use a raw field at the beginning to fill out this duplicates in the database, but sometimes it failed. But we can use the names and then to run the large language models to get a name of this company, and then we can compare. So if the name is the same, then obviously we're going to choose the one here. Now some logic here, yeah. And after we do that, then you can see we only have 19 symbols here because we cleaned that one, the AAC QU, yeah. So that's the ETL process, and they help us to prepare the final table, as I mentioned, which is will be used as a data source to build your own alpha, beta, and covariance matrix. Next demo, I'm going to show you how we're going to update alpha and beta. So assume that you get a new alpha estimator or beta estimator. You want to know how to deploy it. So first of all, it's about update. So we go to the algorithm, alpha builder. So you see we have alpha, a random alpha here. And because it's random, so it's for simulation. So for example, I'll assume that all the returns is just random numbers from 0.5 to 1. So now I change it to 0.1. I think this distribution can be different. And then for beta, I also do similar. So I think it's 0.5, for example. Now with this one, you see I update alpha and beta estimator. And because my algorithm is going to use this alpha and beta, so I want to make sure when I update it, it's not going to violate my algorithm implementation. So what do we do? We just do git int and then git commit update alpha and the beta. Then we push. Now we push the updated version of alpha and beta to the to GitHub repo, and let's look at how it works now. So now I'm updated. I mean, in this case, I'm updated alpha and beta. So my GitHub will check if there are any changes in my source code. So it finished the checking, and then you need to check if there are any change in the infrastructure, and no infrastructure changing, but it detected I have alpha and beta changing. So in this case, it's going to build the doc image of alpha and beta. So it will take some time to do that. Okay, as you can see, the doc image here, we finished the building. So now it's going to deploy. Because as you can see, alpha and beta, they're updated. And then we need to update the service. So now my Terraform is going to work on. The first one is going to deploy the latest version of random alpha estimator. Okay, as you can see, so we alpha and beta, we update it. We finish the deploy here. Then you can check the clock run, as you can see 5 minutes ago, 4 minutes ago, because it's the latest version. Next one, I'm going to show you how to update a trading strategy and also the execution of the trading orders. In my project, I put all my trading strategy on the folder trade, and it basically composed of a workflow file. It's going to tell the workflow, say, which alpha we should use, which beta we should use, and which optimizer or like which covariance we should use. After that, then we can deploy this workflow. I try to show a very simple example. Say, I'm not going to modify the algorithm, but if you want, you can basically change the address of your alpha and beta. I just make a very small change. Let's say, remove the space. There, as you can see, which means this file, there's a change. And if I'm pushed to GitHub, it's going to detect, say, okay, your trading strategy is changed, and then we need to update it. So let's say git add, git commit, update trading strategy. Then we push. We update the trading strategy. So let's wait for 30 seconds, I guess. Here, you can see the workflow. So I have this beta portfolio workflow. The update it, we just update it here. So we click it and we do execute, run it. So this will first calculate the alpha, beta, okay, alpha, beta covariance matrix here. We did optimization. You just run the solver of the optimization, and then to send the order to Alpaca. So after we do the solving, it tells you we need to spend, like for example, for 10,000, we have Apple allocation is a 3,567, and this is for Amazon and for Google. Okay, thanks for watching the demo. So as you can see, the functions that my current project provides. But of course, there are a lot of work I can do in the future. So basically, there are three things I think, and we'll focus in the current, next stage. One thing is to create a dashboard. So, because by creating a dashboard, it's easy for me to visualize my backtesting results, and also it's going to help me monitor the performance of my portfolio in live trading. Second of all, I want to do is to increase the frequency of trading. Yeah, I think it's a good idea, and I'm going to try to improve the ETL process to accept the stream data. But in that case, I might not be able to use a cloud run. Yeah. And then I want to try some trading strategies. So, because in this video, I only show the variance, like mean variance optimization problem. Then maybe I can try some pair trading. So I'm happy to deploy a pair trading strategy to see the performance and share with you. Of course, I will create a tutorial about deploying the strategy using my current project. Yeah. That's all. And thanks for watching. And here's my email address. If you have any feedback about the video, about the project, or if you have any suggestions, please don't hesitate to drop me an email. if you have any questions about quantitative finance and regarding the strategy developing or like a platform developing, or any fintech projects you think and can help, please don't hesitate to drop me an email. I also provide my LinkedIn here, so just find me and contact me if you want. Yeah. Uh, thanks for watching this video, and hopefully that is another chance that I can see you in the future to show some other progress about this project. Yeah, and have a nice day.